lesson is on rhombi, which is the plural of rhombus, which for you guys is the diamond, and squares.
We should just say rhombuses.
Rhombuses, it's like saying rhinoceroses. Okay. So rhombi are parallelograms. So they have all of the properties of a parallelogram. Opposite sides are parallel. Remember, that's the definition of a parallelogram. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. They have the properties of a parallelogram. They do not share the properties of a rectangle, though. So rectangles, the whole diagonals are congruent and 90-degree corners. That's properties of a rectangle. Rhombi has its own. So in a rhombus, all four sides are congruent. In a rhombus, all four sides are congruent.
It kind of looks like a square.
It's kind of a square that's kind of got pushed over a little bit, yeah. The diagonals are perpendicular. What's it mean to be perpendicular?
90-degree angle.
They form a 90-degree angle. Good. I guess I need pictures, huh?
Wait, perpendiculars.
Perpendiculars, they intersect at 90 degrees. That is not a good rhombus. So all four sides are congruent, and then our diagonals, still not a good rhombus, but it's okay.
The difference between a rhombus and
What's that?
the difference between a rhombus and a rectangle is just shorter.
The main difference between a rhombus and a rectangle is that all four sides are congruent. And that the angles, the corners aren't 90 degrees.
Because they kind of just look shorter.
Yeah, so the diagonals are perpendicular. And then now, the diagonals also bisect opposite angles. So what does it mean to bisect? Cut in half. So our diagonals bisect opposite angles. So if I've got my rhombus, and then the diagonals are going to create congruent relationships at each angle. So whatever that angle is, it'll be bisected. It's a lot. It's a lot in that little space. So each quadrilateral is a rhombus. Find the missing measures. So remember, we have all of the properties of a parallelogram, plus now these three extra properties. So they told us JK is 12 and JN is 7. So they're probably going to want us to do the Pythagorean theorem, so we can go ahead and eliminate that. MN and MK are out. Y'all can take that off the paper for right now. So what would the measure of JM be? In a rhombus, all four sides are congruent. So if one side is 12, the other three sides have to be what? 12. Hooray, 12. No, we could find it because the perpendicular relationship in the middle creates right triangles, and we can use the Pythagorean theorem. Well, we'll cover that a lot in Unit 5.
Is the middle always going to be 90 degrees?
For a rhombus, yep. For a rhombus, these diagonals will always be 90. That's going to come into play when we're finding other angles, yep. All right, and then it says, what's the full length of JL? So if Jn is 7, what's Ln? Why would Ln be 14? It'd be 7 because it still follows the properties of our parallelogram in which diagonals bisect each other. So if one piece is 7, the other piece also has to be 7. So the full length would then be 14. Good job. Number 4. We got a lot of angles. It's going to be fun. So we have our parallelogram rules, which tells us that opposite angles are congruent. Correct. So we know opposite angles are congruent, and we know consecutive angles are supplementary. 3 would be 38. How come? Because in a rhombus, diagonals bisect opposite angles. Good job. So what would that make 4 and 5? Also 38. Right, because in a rhombus, it still follows our parallelogram rule. So it still is true that opposite angles are congruent. So 3, 4, and 5, we already know them. There's also one more we know without doing any math. 8. What would 8 be? 8 would be 90 because in a rhombus, our diagonals are perpendicular, which means they form a right angle. Now for 1, 2, 7, and 6, we've got a couple of options. Okay? We can know that that's a right angle, so we could just do the triangle sum theorem, or we can use our parallelogram rule. You can do triangle sum theorem. I'm going to do parallelogram rule so we can practice it more. So the parallelogram rule tells us that consecutive angles are supplementary. So if the full measure of this angle is 76, how would I find the measure here? What would this measure be?
Wouldn't you have to find the measure that angle?
What's that?
Wouldn't you have to find that angle measure first?
What angle measure?
The number 1.
I can't, I mean, I could find one by doing the triangle sum theorem, but I want to find that light blue angle using our parallelogram rule because I want us to practice our parallelogram rule some more. Consecutive angles in a parallelogram are what? Supplementary. So what would the measure, so let's say this light blue angle is our dog theta. Okay. So theta plus 76 must equal 180 degrees. What's that? 38 plus 38, the full angle. We just added the two given together. Great question. Because consecutive angles in a parallelogram are supplementary. Consecutive means they share a side. They're next to each other. Yeah.
The left side.
And so is the right side. So if we wanted to find 7 and 6 first, we could have gone that way. Yeah.
So top left or the bottom right side?
Top left or bottom right. Yep. 7 and 6 will be the same as 1 and 2. Yep. Absolutely. Because opposite angles are congruent in a parallelogram. So we subtract 76 from both sides. And we know that full angle measure is 104. So the full measure is 104. So how would I find the individual? We know that angle has been what by the rhombus diagonals? It's been bisected, which means it's been cut in half. So we can just divide both by 2. And hopefully we get the same thing that we got over there doing the triangle sum theorem. 104 divided by 2 is 52.
Wait, sorry,
What do you mean? The angle has been bisected by the diagonal. So we just divided by 2. I wanted to practice this one too, because you guys have got a ton of practice with the triangle sum theorem, but not as much practice with our parallelogram properties. 76 where? Yep. So you add the 2 angles together. That's another reason I want to do it that way, because, yep. Yeah, it's the full measure of that corner. So we just add up this whole and it gave us 76. Looking at number 5. We've got a bunch going down. So we got ZY is 34. Yep, we can always find sides. WY is 38, which means each one of these will be 19. Wait, how'd I get that?
Yeah, WY.
WY is 38, so I said each individual side is 19. Because it's being bisected, so I just divided 38 by 2. And then I've got ZXY measures out to be 34. So before we even look at the blanks, we can fill out almost this entire rhombus outside of finding the measure of ZX, because we're not using the Pythagorean theorem yet. What would the measure of angle WXZ be? How come? It is 34, and it is 34 because in a rhombus, what does the diagonals do to our angles? It bisects them. Yep. And then what would WZX be? It would be the same thing, because in a parallelogram, opposite angles are congruent. So does this shape follow the alternate interior angles theorem? If these lines are parallel, if this line is parallel and the transversal, are my alternate interior angles congruent? Yes. Okay, what do we know happens in the middle? How do our diagonals intersect? They are perpendicular, so they form 90-degree angles. And then, how would I find the missing angles? What would the full length of angle Z be? What's the full length of angle Z? Which is 68. So what would the full length of W be?
Wait a minute.
I'm listening.
So 68. And then
So wait, would you do
up there? Oh yeah.
Yeah, because they're supplementary. Consecutive angles are supplementary in a parallelogram.
Oh, and
So we subtract 68 from both sides. So theta measures out to be 112. And then what does the diagonal do to that angle? It bisects it. So if we divide 112 by 2, what do we get? 56. So all of our other angles are 56. Pretty cool, man. So what is the measure of WZ? In a rhombus, all four sides are congruent. So what would WZ be? 34. VY. ZB. We can't find it. Not without using the Pythagorean theorem. ZX. Same thing. Not without using the Pythagorean theorem. How about WXZ? 34. Remember, guys, just follow along your vertice trail. WVZ. 90, because in a rhombus, what happens to our diagonals? They intersect. Perpendicular angles. Good. ZYW. 56. And XYW. 56. Very good. So that is our rhombus. We've got one more parallelogram left. And it's a doozy. Because it's just number 1 and 2 and 3. Everything we learned about parallelograms. Everything we learned about rectangles. And everything we just learned about rhombuses. The rhombi are qualities of a square. So a square has all of the properties of a parallelogram, all the properties of a rectangle, and all the properties of a rhombus. It's like the mega parallelogram. Super Saiyan parallelogram. Basically, it is the equilateral equiangular. Because we can use all of those properties to help us find something. So opposite sides are congruent, opposite sides are parallel, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Those are the properties of a parallelogram. 4 right angles and our diagonals are congruent. Those are the properties of a rectangle. And then finally, 4 congruent sides, perpendicular diagonals, and diagonals being bisected is the property of our rhombi. So it says ABCD is a square, and the length of our square is 11. If one side of my square is 11, what are the measure of all of my sides? 11. All of them, because in a square, it follows the property of a rhombus and has 4 congruent sides. Even the inside angles. Now, you guys are really going to like the inside angles because there's only 2 options. It's either 45 or 90, because inside where it meets, those are perpendicular. Our corners are all right angles. And because it has got the rhombus properties, all the corners are also being bisected. I am. So what about DAB? Angle DAB. DAB. 90 degrees. AEB. Diagonals are perpendicular, so it is also 90. CBD. So this would be a 90-degree angle, and the rhombus tells us that those angles are bisected, so it would be 45. Fantastic. Pretty awesome. BAC.
Oh, heavy.
BAC. 45. So The other two, so DAB would be this full angle. Come on now. That would be this full angle, which we know the corners of a triangle are what? You got to flip for me? Thank you. We know the corners of a square are 90 because they have the property of a parallelogram of a rectangle. And then in the middle, these guys are also perpendicular because they have the property of a rhombus. So the only two angle options for a square are 45 or 90.
Yeah.
Yeah. Let's put some algebra in there, though. It says MNOP is a rhombus. Find the measure of MP. What do we know about the sides of a rhombus? They're all congruent. So we just set them equal to each other. All four sides are congruent in a rhombus. So 9x minus 77 equals 3x plus 7. We're going to subtract 3x from both sides. So 6x minus 77 equals 7. Add 77 to both sides. So 6x equals 84. Divide both sides by 6 and we get 14. But is that what they wanted?
No.
They want the length of MP. So what can I do with that 14 to find the measure of a side? We're going to substitute it into one of the sides. You want to go MN or PO? Probably PO. How come? Smaller numbers. We ain't got to deal with craziness. So 3 times 14 plus 7. 3 times 14 is? 42. And then 42 plus a touchdown equals 49. So if one side is 49, what does that mean about all four? They're all 49. Yeah. CDEF is a rhombus. Find the measure of angle FED. What do the diagonals do in a rhombus? The diagonals bisect. So if CFD and EFD have been bisected, that means that they are equal. Good job. So we can set them equal to one another because they were bisected by diagonal FD. So we subtract 5x from both sides. What's wrong? Okay. Yep. Then we got 3x minus 20 equals 1. We can go ahead and add that 20 to both sides. So 21 equals 3x. Divide both sides by 3. X equals 7. It wants the measure of FED. So we've got to do a little bit of work to get there, don't we?
Yeah.
Yep. So we need this We want the measure of FED. This is the one we're trying to find. So let's take that 7 and substitute it into our original problem. So 5 times 7 plus 1. 5 times 7 is 35. And 35 plus 1 is 36. That means each of these individual angles measure out to be 36.
So what do we do with the 36?
What do we do with the 36? Well, what do we know is true about the full measure of F? If we add those two together, the full measure of F is 72. F and E are consecutive angles. So because they are consecutive, that means they are supplementary. So we take our 72 plus the measure of, did they say FED? And that equals 180. Subtract 72 from both sides. So the measure of FED is 108. So that's another reason why I wanted to walk us through it the way earlier. The way you were doing it earlier with the triangle sum theorem, that would still work, but you're probably doing about the same amount of work. Uh-oh. STUV is a square. SW is 2x plus 13. And WU is 8x minus 41. They didn't even try to challenge us. They put them on the same line. What do we know is true about the diagonals of a parallelogram? They are bisected by the other, which means that those two are congruent, which means we can set them equal to one another. So 8x minus 41 equals 2x plus 13. Subtract 2x from both sides. Six x minus 41 equals 13. Add 41 to both sides. 6x equals 54. Divide both by 6 and we get x equals 9. But they didn't want what x equals, they want what SW equals. So we just plug it back into the equation they gave us. They said, hey,
yeah, you do.
SW equals 2x plus 13. So we just take that 9 and substitute it in. 2 times 9 gives me 18. And then 18 plus 13 is 31. So what they want us to solve for, though? VT. So we know that the two are congruent, so we just multiply by 2. So VT equals 31 times 2. So the measure of VT is 62.
That makes sense. Good.
I hope so. Hopefully this last one makes a little sense too. Now, If ever there was a situation where geometry students go around their elbow to get to their nose, it is in a situation just like this one. Exactly. Why would you go around your elbow to get to your nose when you can just go to your nose?
I don't know.
Well, alrighty then. So it said solve for x. It told us this was a square. So in a square, what would the measure of SGI be? FGI, I'm sorry.
9.
FGH would be 90. What would FGI be? 45. How come? Because 90 has been bisected by the diagonal IG. So don't double 7x plus 3 and set it equal to 90. Just set 7x plus 3 equal to 45. Too many times I've seen you kiddos go and try to double 7x plus 3 to make it equal to 90. Because it's a square, it's being bisected by that diagonal. So just do the bisected measure. So we subtract 3 from both sides. 7x equals 42. Divide both sides by 7. X equals 6.